Alrighty, my friends, let's see. Today we're going to talk about undoing chain rule through integration. Ooh, that sounds fancy. So you want to take the derivative of the following. I like to think of this as the sine of x cubed. So to take the derivative, the 3 comes down, the sine, leave it alone, leave the squared, and then multiply by the derivative of the inside, so cosine x. So we're asked to look at undoing that process. Well, let's see. That was the original inside. Original inside. And that's the derivative of the inside. Derivative of the inside. So if I choose some letters here, if I think of f of x as g of h of x, let's examine what's going on. So we're stating that g of x in this case is x cubed, and h of x is the sine of x. And then for f is g of h of x, and f prime is g prime of h of x, and then times times h prime of x. That was a close one. H prime of x. So, if we can, to undo the process, if we can identify something such that the inside of the function is here, or a specific function is here, and then its very derivative is sitting out here, that might be a useful move. So I think that's what I want to focus on. I want to focus on, can I identify an inside function whose derivative is sitting outside? Now, it could look a little different. I could have the sine of x as my inside function, and then an 8 cosine x as the outside function. But 8 cosine x, ignore the 8, because we can ignore that. If I have the sine of x as the inside function, cosine x is the derivative of that inside function. Ignore the constant multiples, because remember, we can take those out and kind of ignore them, and then bring them back at the end. So let's take a look here. I don't know if this is less scary, but my idea was to say, let's focus on inside, outside. So here I have an outside. An outside is my squared function. And then I have an inside. My inside is this 4t cubed. So my inside is 4t cubed plus 3t. And then my derivative of the inside is 30, nope, I got confused by up there, is 12t squared plus 3. And out here I have a 36t squared plus 9. But can't I think of that as 3 times 12t squared plus 3? So this now matches. So what I'm saying is we have an integral, and we have something squared. On the previous page we called this h, I believe. And then we have h prime out here. Okay, so ignoring that 3, so take that 3 out. Now we can say, well, to underderivative this, to integrate this, and ignore my sloppy notation there, I know it's not perfect. I'll put a dx there to make you feel a little bit better, but I still don't like it completely. But if I say, well, this is h squared times h prime, well, before that was just h cubed. But I have to put a 1/3 in front. Get rid of it. So that cancels out that 3. Oh, okay. So that's just going to be h cubed plus some sort of constant. So plus c, plus c, plus c. So my thinking is, that didn't let me shrink. My thinking, let me shrink. Come on, you can do it. I believe in you. There we go. My thinking is the derivative of h cubed is going to be what we started with. I can ignore the plus z. And let's say, okay, not h cubed, but the derivative of h was 4t cubed plus 3t. So the derivative of that is 4t cubed plus 3t squared times the derivative of the inside, which is 12t squared plus 3. And that's what we have here. Ooh, okay, so this is a little spicy. So if I can identify the inside, if I can then identify the derivative of the inside, and if those are sitting there, then I can do this problem. Now this process is often called u-substitution. So let's think of why. Make u your inside. Just like we made h our inside, we just chose a different letter. Doesn't matter. Find the derivative of u. Not du dx. That was a close one. It's du dt is 12t squared plus 3t. Now replace things. So 4t cubed plus 3t, I'm going to replace with u. And then, I'm not sure what this is, 36t squared plus 9. But I can solve here for dt. So dt is du over 12t squared plus 3t. And we're playing fast and loose with kind of how we treat these things. But I can put this as du over 12t squared plus 3. There's no t there. I got confused by the t's. There we go. Well, if I simplify, that just becomes the number 3, like we talked about before. So this is really the problem 3u squared du, which is just going to be u cubed. I could put the 1/3 and the 3, those will cancel out, plus c, which is really 4t cubed plus 3t cubed plus c. Ooh, okay, so this is the exact same problem. So we'll go through the same process. So if you didn't understand on the previous one, it's the same process. But let's see what the difference is. We've got some numbers here. So let's see. This is a t integral. Everything's dependent upon t. But we're going to make a change. We're going to do that same thing. We're going to say, let's make the u the inside. 4t cubed plus 3t. So then du dt is 12t squared plus 3. Let's solve, because I know we're going to need that. dt is du over 12t squared plus 3. Now let's replace things. I'm going to rewrite as I replace. So 4t cubed plus 3t, that's u. And then 36 plus 9, I'm going to call that 3 times 12t squared plus 3, because I know what's going to happen. So I'm trying to show you. And then dt is du over 12t squared plus 3. So I can cancel those out. Now, you notice I didn't put any numbers down. These were in terms of t, now we're in terms of u. So let's go ahead and say this is when t equals 1 and when t equals 2. That's what this is saying, from t equals 1 to t equals 2. Well, if t is 1, what is u? Think here. That's 4 plus 3, so that's 7. If t is 2, then u is 8 times 4, which is 32, plus 3 times 2, which is 6, so 38. All right. Now let's finish the problem. So what we can do is we can say, well, we already figured out that was u cubed, and we're going from 7 to 38, so use our evaluation bar, 7 to 38. So it's the cube root, no, the cube of 38, not cube root, minus the cube of 7. And that should be our result. So the only real difference was the numbers we had to deal with. And the big change that we have to pay attention to is they were 1 and 2 when we were dealing with t. They became 7 and 38 when we went to u. So this is where you think about what your big conclusions might be. To me, the big conclusion is find the inside function, notice its derivative, fill in u and du so that you only have u's in your integral, and then integrate. Those are kind of my big noticings that we just did. All right, so we have a couple of examples here that I'll wander through for you to finish off. So this one, when I'm doing substitution, I'm looking for an inside function. So in this one, I see that square root, and I'm looking inside. So let's suppose that u is 1 plus x cubed. And my du dx is 3x squared. Well, that means that dx is du over 3x squared. You don't have to think about it this way. I can explain it different ways, but this is a way to think about it. So let's go ahead and replace. So x squared, let's leave that. 1 plus x cubed is u, and then du over 3x squared. So that means we're dealing with, see how the x squareds cancel? And then I have a 1/3. I'm going to kick that all the way out. I don't like this 1 over the square root of u, so I'm going to think of that as u to the negative 1/2 du. Now it's time for me to integrate. And to integrate, all I need to do is say, whose derivative is this? So let's add 1, u to the 1/2, compensate with a 2. Don't forget that pesky 1/3 hanging out. Add a plus c. And then that's going to be 2/3. The u is really 1 plus x cubed. And that's to the now 1/2 plus c. If you're not convinced you're right, just take the derivative. So we got 2/3, 1/2, 1 plus x cubed to the negative 1/2 times 3x squared. And then the plus c goes away because the derivative of a constant is 0. Those cancel. Those cancel. So it's x squared over square root 1 plus x cubed. So we did that. The next one, we've got so I see an inside there of the square root. I could probably do this without u-substitution, but we're practicing, so I want to do it. My inside is 1 plus t. So then my du dt is just 1. So that means du is dt. So I'm going to have the integral. Kick that 1/2 out, and that's going to be 1 over, or maybe I should just replace the dt, du over the square root of u, which I'm going to think of as u to the negative 1/2 du. So then whose derivative is u to the negative 1/2? Well, that's got to be u to the 1/2. I had the 1/2, and I now need a 2 plus c. So that's going to give me a 1/2 and 2 cancel out. That's going to give me u to the 1/2, which is 1 plus t to the 1/2 plus c. If we don't think that's right, again, you could take the derivative and see if that works. And now for the next one, see, these get a little trickier. We have 2x e to the x squared. Sometimes your inside is hiding. If we think about this, this gives me a hint, because I see that your inside on an exponential function is actually the exponent. So we need to make sure that although that looks like an inside, it's really in the exponent. So let's go ahead and identify the x squared as my inside. So u, that's not a u, u equals x squared, which means du dx is 2x, which you could think of as du is 2x dx. And now let's plug things in. So we have 2x, e to the x squared is now u, du, sorry, my brain fell out, over 2x. Your 2x is canceled. So we wind up with e to the u du, and that's got to be just e to the u plus c, where e to the u means e to the x squared plus c. Now this one looks really spicy. It looks very terrifying. But let's think. I see an inside. In fact, I'm going to change one thing as I write this. I'm going to get rid of that 2, and I'm going to write it like this. So I see an inside. I see 2 insides. So I could, if I want to, do a double substitution. I could play with the tangent first. In fact, let's do it that way. Suppose I have u as the tangent of x. So that means du dx is secant squared x, which means that dx is du over secant squared x. You guys are like, this is terrifying, I don't like this. It'll be okay. So leave the 5, leave the natural log. Tangent is now u. And we're still squaring that whole thing. Dx is now du over secant squared x. Secant squared x. And I still have sine x, cosine x. So secant and cosine are going to cancel out in some way, but I still have a scary piece. So I'm going to do it again. I'm going to say, okay, well, this is a second substitution, so we'll make it double u. Get it? W is the natural log of u. So dw du is 1 over u, and du is u dw. So let's see what we have here. Well, what we have here is a big mess. We can do it, we can do it, we can do it. We have 5, u is now, natural log of u is now w squared, du is u dw. Let's simplify this. So that's sine, cosine, and that's, if I think of that as 1 over cosine squared, that means I'll have sine over cosine. Wait a minute. That's tangent. Oh, this got super spicy. Keep breathing. I'm going to do this another way. So sine over cosine is tangent. So I have 5w squared u du over tangent x. But I know that tangent x is u, so those will cancel out. So I have 5w squared, that's supposed to be a dw, I tried to fix it and I made it worse, dw. So I could find whose derivative is w squared, it's 1/3 w cubed, and I could go from there. But let's try it a different way and see if it turns out to be easier. So what I want to do is I want to pick a scarier u. So for my u, let's pick the whole inside. I know it's going to have a double inside, but let's see how it goes. The natural log of the tangent. So that means du dx is 1 over the tangent times the secant squared. For funsies, let's simplify that. So that's cosine over sine, 1 over cosine. Ooh, that's sine cosine. So let's replace 5. The natural log of the tangent x is now u squared. Dx I didn't solve for, but if you multiply that over, dx is going to be sine x cosine x du over sine x cosine x. Now I can cross this out. Ooh, this is where I was before, but this seems easier. It's a faster move. So if I am more aggressive in my u, I get to a better place. So that means 5u squared. So that's going to be u cubed, 1/3, keep the 5, plus c, which is 5/3. My u, that's the natural log of the tangent of x, cubed, plus c. Whew. All right, so we covered some stuff. The focus is on find what is inside. And you can do good stuff once you find that. Now, there are other methods of integration, so let's not pretend that this is the only thing we have. But this is a useful method if you see someone whose derivative happens to be sitting there. This is a mysterious one because you had to do some work to get there.